All right, today we're going to do section 8.5. So we are still working on area. Today we will be talking about area of parallelograms. But to review, we've got some warm-ups that have us finding area of other polygons that we've already worked with. So let's take a look at those. On number 1, what type of polygon do we see? A quadrilateral, more specifically, a rectangle. We talked about how to find the area of a rectangle. What's our formula? Oh, careful. Just base times height. On a rectangle, it's just base times height. What's my base? 9. My height. So altogether I get 36 meters squared. Good. On number 2, what type of polygon do we have? A square. Okay, squares are rectangles, so if you want to think about it like a rectangle, you can. But it is a square. So what is our formula for the area of a square? Side length squared. I heard some people say it. So what's my side length? 13 squared gives me 169 yards squared. On number 3, we have a few different shapes, so we are going to find their areas individually, and then what will we do with them? Put them together by adding. So for our first polygon, I believe is right here. They already outlined it for us. How would I find the area of that part? Keon. Base times height. Okay, so what am I multiplying? 4 times 4, and I get 16 centimeters squared for that first one. Then let's move over and do the one on the side. Who can help me out with the one on the side? Ken?
Base times height.
Base times height, so what do I get?
16.
Also 16. 8 times 2 also gives me 16. Who can help me out with my last rectangle at the bottom? Angel? 10 times 2 gives me 20 centimeters squared. So when I add them all up, what do I get? 52 units centimeters squared. Questions about 3? We'll move on to number 4. We've got a different formula we have to use on number 4. Who can raise their hand and tell me what it is? Jaden? Yep, 1/2 base times height for the area of a triangle. What is my base? 18, and my height? So we've got 1/2 times 18 times 5. You can take half of 18, or you can multiply 18 times 5 first, and then take half of that. Half of 18 is 9. 9 times 5. 45. My units? Squared. It's area. Anytime we find area, our units should be squared. All right, we've got some notes to fill in today. First, bases of a parallelogram. When we talk about the base of a parallelogram, you can be talking about either pair of parallel sides. So we kind of get to choose which ones we are going to consider to be the bases. The height of a parallelogram is the shortest distance between the bases of a parallelogram. Much like a triangle, the height is perpendicular to the bases, and it could be inside or outside the parallelogram. All right, so our formula for the area of a parallelogram should look familiar. It's the same as which other area formula?
Rectangle.
Rectangle. It's the same as the formula for a rectangle. Now the reason that it works out being the same is that you might be able to imagine if we were to take this piece here where they drew in the height, and you can see they marked it being perpendicular to a base. But if we were to take this whole triangle and cut it out and move it over and reattach it or tape it back on to the other side of our parallelogram, now all of a sudden if I reattached it over here, after I cut it off from the other side, what does my shape look like if I were to do that?
That's the picture, right?
Well, I've colored on it now. Now it's going to be a rectangle, which is why it works out to be the same.
So it is the picture, right?
Yes, I'll take my markings off of it so you can get the original picture, not the one that I colored all over. So our formula is area equals base times height, same as a rectangle, because if we were to rearrange a parallelogram, we could make it into a rectangle. Now the difference is that the height on a parallelogram is never going to be a side of the polygon. The height of a parallelogram is always going to be perpendicular to a base. Notice the right angle. It's important that we mark that right angle for our height to be perpendicular to the base. All right, our examples are already on your paper for you. So on example 1, what formula am I using? Base times height, still B times H. What is my base? And my height is 9. And if I take 5 times 9, I get 45, and my units would be meters squared. That's all we're doing, finding the area of a parallelogram. All right, on number 2. Again, we have a parallelogram. Our area formula is still base times height. What's my base? 17, and my height is 12. Notice that on this one, the height is outside of the parallelogram, but we knew it was the height because it was marked as being perpendicular to the base.
Right.
Julian?
It doesn't look like it work for that. Because if you take the triangle and put it over there, still, it's not a perfect.
So they could have drawn the height inside. It just would have been towards the top instead of the bottom. And then if you cut off this gray one, tack it over there, then it forms that rectangle. Does that make sense?
Yeah.
Okay. Or if you think about taking it from the right side, notice that this triangle here is identical to the one they drew outside. Does that make sense? Okay. All right, if we take 17 times 12, what do we end up with? 204, and our units? Centimeters squared. On the examples on the back, 3, 4, 5, starting at the top. These ones are a little bit different because this time we are given the area, but we are asked to find either the base or the height of these parallelograms. So we use the same formula. The area of a parallelogram is equal to the base times the height. This time we fill in what we know. Do we know the area for number 3?
Yes, ma'am.
63. Equals, do we know the base?
No, ma'am.
No, so we're going to leave it as B, and the height is 9. How are we going to get B alone? Divide 63 by 9. B equals 7. What are my units? Should they be squared? No, because we're not finding area. If we're not finding area, we do not square our units. On example 4, start the same process over again. What am I plugging in for A? 144. What's going in for B? 16. And H? H, we're leaving it alone. We don't know the height yet. To get H alone, we are going to divide by 16. H equals 9 feet. Not squared because it's not area. All right. Example 5. Let's do it one more time. What's going in for A? 55. In for B is B, and in for H. To get B alone, we have to divide by 5, and B equals 11 centimeters. In our next set of boxes, we've got the area of a rhombus. So our formula is A equals 1/2 times D1 times D2, where D1 and D2 are the diagonals. So we've got this picture here that shows a rhombus. We know it's a rhombus because all of the sides are congruent. Parallelogram with all sides congruent. The diagonals cross through the middle. So this one that goes up and down through the middle, see how that lines up over to the side with D1? If we take this height, that's how they're getting that D1 on the side there. Same thing with the diagonal down the middle. They're D2. They're measuring that from the middle, but they're showing that that gives us the length of that other diagonal. Let's talk about these examples. Once again, they are already written in on your notes for you, so you do not have to copy down the diagrams. We are going to use that formula that we just wrote down. The area of a rhombus is equal to 1/2 times what? D1 times D2. So D1 and D2 are referring to what? The diagonals. So we have to refer to the diagonals of our rhombus. Now on number 6, they showed it on the outside. So if I were to move this 8 meters in, that's the diagonal that goes down the middle. And the 14 meters at the bottom would give us the same length as the diagonal that goes from side to side. So it does not matter to me which one you call D1 and which one you call D2. So what do you want to plug in for D1? Okay, which makes D2 14. Much like when we do this with triangles, we can take half of 8 and multiply that to 14, or we can take 8 times 14 and then take half of it. So if you take half of 8, what do you get? 4 times 14 is 56. What are our units? Meters squared. Why do we square it? It's area. We always square our area units. Now, on number 7, it's set up a little bit differently. They gave us the pieces of our diagonals. So before we get started, I want to know what you think D1 should equal. If D1 equals 6, what does D2 equal? No. No. 12. So if you consider D1 to be the 3 plus 3, that whole diagonal, then 6 is appropriate. Which means that to get diagonal 2, we would have to take 6 plus 6 to get 12.
So which one's D1 and which one's D2?
So the way that I have it labeled, D1 is the short one here. It doesn't really matter. If you were to label D1 as being 12 and D2 as being 6, it would be fine. D1 and D2 just mean that they're two different diagonals. Do we have questions about how we came up with 6 and 12? So we still need to find the area. So we will plug in 1/2 times 6 times 12. Half of 6 is 3. 3 times 12 is 36. Units are feet squared. All right, area of a regular polygon. So now, anytime we have a regular polygon, if we're given the right information, we would be able to find its area. Real quick, what does it mean to be regular? Equilateral and equiangular. Good. So all the sides are congruent, all the angles are congruent. Ooh, running out of space. All right. For your picture, I believe that we should be drawing this second one. I believe that's going to be more useful for us. We need to know what the apothem is. All right, when we talk about the area of a regular polygon, the formula is not very complicated. 1/2 times little a times capital P. It is important that we write down that little a stands for apothem. Apothem. And that capital P stands for the perimeter of the polygon. Now, apothem is something that we have not talked about before. The apothem goes from the center of the polygon. What kind of angle do you think it makes with the side? A 90-degree angle or a right angle? So the apothem is perpendicular to a side of the polygon. If you want to write that next to apothem, you can. It's perpendicular to a side. Notice that the apothem does not go to a corner or to a vertex. We call that the radius. We don't really use that to calculate our area. At least not directly. Finally, perimeter is something that we've reviewed a little bit, but how do we calculate perimeter of any polygon? Add up what? Add up the sides. So add all sides to find your perimeter. Or you can take the number of sides and multiply it by the side length. Whichever way you want to do it is fine by me. Questions about getting these boxes filled in before we do a couple examples?
No.
We're ready to move on? All right. On number 8, we have a regular polygon. We know that because they told us in the directions. We are finding the area of a regular polygon. So we are going to use that formula that we just wrote down, which is A equals what? 1/2 apothem times perimeter. So capital A equals 1/2 little a times capital P. On number 8, they were nice enough to label our apothem for us. What is it? 6. So that 6 is my apothem. Does that make 5 my perimeter? No. How am I going to find my perimeter? Add all the sides or take 5 times 5 because there are 5 sides. Either way you go about it. What's our perimeter? Perimeter equals 25. So when we go to calculate our area equals 1/2 times 6 times 25. Half of 6 is 3. 3 times 25 is 75. They didn't put units in there, so if you were not to put units, if they don't put them, that's okay. Technically, we should put units squared, but if they don't put it on there and you don't put it on there, I'm not terribly worried about it. Questions, concerns about number 8? All right, let's take a look at number 9. Number 9, they did not label for you yet. So let's go ahead and label it. We'll label that side 10. And we'll label this as 8. Why not? All right, what is A on this one? 8. A is equal to 8. That's my apothem. And then to find my perimeter, or capital P, what am I going to do?
10 times 10.
Not 10 times 10.
10 times 8. 10 times 6.
10 times 6, there are 1, 2, 3, 4, 5, 6 sides. So 6 times 10 gives me 60. So we go to our A equals 1/2 times. What's going in for A? Little a?
8.
And in for capital P?
60.
Half of 8 is 4. 4 times 60 is 240. So technically we would want 240 units squared. But again, if they don't put units and you don't put units, we'll call it even.